So we have talked about the eyewall a lot already. We talked about how it's tight and small for a very intense cyclone and larger and more widespread, let's say, because of during a less intense cyclone. So the pressure drop is much larger as the intensity increases, and we said angular momentum conservations seem to create this outward bending eye wall, giving it what we call the stadium shape. We said how inertial stability is high at the lower part and low at the upper part, and so on. Once the cyclone reaches its maximum intensity and the eye wall has gotten as small as it can for that particular balance of the eye pressure and the winds, the energy, angular momentum, and so on, it actually begins to lose its moisture and energy, so it begins to fall apart. And then depending on what happens to the cyclone after that, a new eye wall may form and come in, and the cyclone may re-intensify, or if it is the end of the cycle, then obviously cyclone may fall apart. So the eye wall replacement cycles are obviously for those where the cyclone is still alive and transitioning and is probably changing intensity, rebuilding an eye wall, re-intensifying, and so on. So let's start with this Doppler radar image of Hurricane Ivan at a particular time on 10th September 2004. This is the column maximum reflectivity in dBz. So radar reflectivity image from Kingston, Jamaica at 14:45 UTC, 10th September 2004. Note the two concentric eye walls that not completely clear here, but there are two. Every time you have a full circle as opposed to the feeder bands, then that's an eye wall, right? At this time, Ivan had weakened from category 5 to category 4 with sustained winds of 65 meter per second, and then it intensified. Spatial distribution of surface rain rates in Hurricane Georges via TRIM TMI, the TRIM microwave imager, best track maximum sustained wind speed in knots are shown here, and rainfall in concentric bins around the center of the cyclone. So here we have millimeters per hour at two stages. Here on it's going from 15th September through 29th September of 1998, and you can see that it's starting here at rainfall in concentric bins of about 12 to 15 millimeter per hour, jumps directly to almost 38 with various wind speeds. So maximum sustained winds here are shown, and this color here corresponds to the rain. So you can see the winds going from 0 to 110 kilometer. This is the distance, sorry, from the center. 0 to 110 kilometer, 110 to 220 kilometer, 220 to 330, and then these are the winds. So lots of information, but the point is you can see that the going from here on 19th September to 22nd September, the old eye wall here has collapsed and a new stronger eye wall has formed with a much more well-defined eye here with a tighter structure of feeder bands. This is much more disorganized here. Okay, so you can see the rain rates here are very high at 35 millimeters per hour, as opposed to here that it's still high, but it's now not in a as tight a structure as here. So the eye wall replacement cycle, intensifying, weakening, re-intensifying, can happen very quickly over 12 to 18 hours, or it may take several days as it happened here. So going from 19th here to, let's see, this is the same day, different times. So I hope I'm right about that. Okay, so you can see another example here, eyewall replacement cycle in Typhoon Sudal in West Pacific, seen in the special sensor microwave imager. I think this is what I couldn't remember before. 85 gigahertz horizontally polarized image from 8 to 13 April 2004. So the time is going this way here, so April 8th through April 13th, and you can see the shape here. The eyewall is not as well formed as here, and it begin to kind of weaken here, strengthens again, and you can see the eyewall reform. Let's say here it's much tighter than more disorganized in these images here. So it has gone through eyewall replacement cycle. You can stare at it a little bit more than I'm doing here. So you can see here starts pretty strong, and it's really tight and strong here. You can see two eyewalls here. The inner one has kind of disorganized, but the outer one is still very strong and moves in. The inner one dies, and then the outer one has become much larger, and then the feeder bands. This is in the West Pacific, so still northern hemisphere. So you can see, so clearly satellites here are capturing eyewall replacement cycles, and depending on the life cycle of the cyclone and its intensification and re-intensification, there can be multiple eyewall replacements. It's just part of the core dynamics where as we said, the eyewall is very well formed. Strongest winds when it's intensified, it's to its maximum, but then the energy begins to get stripped off of it, and then it weakens and collapses, and then a newer eyewall forms and replaces the old one if there is still energy being made available from the ocean. Okay, that's a short introduction to eyewall replacement cycles.